So good afternoon, sir. So I am JR Mikituan from section Better Guess. So in this video, I'm going to explain my answer about the CO2 assessment. So I'm going to get the new draft of the cargo hold 1 that are flooding. So this is the draft, departure draft. We have a forward draft of 10 meters. Aft is 10 meters. So light shift have a weight of 7,502. LCG is 13.8. 0.08 longitudinal moment, 98,126 and 0.16, and BCG or KG 11.5, vertical movement 86,273, and the number 1 hold, we don't have weight, so LCG negative 63.21, wala, no longitudinal moment, so HKG is 8.0, and no vertical moment. So number 2, hold number 2, 8,950 times his LCG negative 38.91 is equals to negative 348,244.5, and 8,950 times 7.8 is equals to 69,800. So kago number 3 hold, so 9,000 times 11 LCG negative 11.66 is equals to 111 negative 105 120, and 9,000 times 7.8 is equals to 70,200. Number 4 hold, 8,500 times 15.58 is equals to 132,430, and 8,500 times 7.8 is equals to 66,300. And number 5 hold, 7,700 times the negative 40 times 42.32 LCG is equals to 325,864, and 7,700 times 8.0 is equals to 61,600. And the diesel oil, we have 200 weight, and times the negative 32.42 LCG is equals to negative 6,484 longitudinal moment, and 200 weight times the kg 15 is equals to 3,000, and 1,900 weight times the negative 11.23 LCG is equals to negative 21,337 longitudinal moment, and 1,900 times the 12.5 kg is equals to 23,750 vertical moment, and 250 times 751 LCG is equals to 19,377.5 longitudinal moment, and 250 times 15.8 is equals to 3,950 longitudinal vertical moment. And we have there free surface ano ba tawag nito, basta free surface ito 165 dito sa fresh water, as fuel oil 9,284, diesel oil is 342, and inconstant is 60 times the 56.64 LCG is equal to 3,398.4 longitudinal moment, and BCG 60 weight times kg 16.8 is equal to 1,008. So this is the whole total of the weight, 42,062. This is the displacement. and LCG, the longitudinal moment. So how to get the LCG? So divide this just like this. To find the departure LCG, total of longitudinal moment divide displacement. So this divide to displacement, so we have 2.22, and this how to get the kg is departure kg is equal to total vertical moment divide displacement. So ito this divide displacement, so we have 8.75. so in getting the GGO, so free surface divide displacement is we have 0.22 mtm, so metric ton meter. So Badalys in kg, so to get the Badalys in kg, we have the weight and TPC. To find added weight equivalent or loss of buoyancy is we're going to get the permeability times volume times the density of water. Thus divide the TPC. So this is the permeability, 0.6, the volume we have 18, 30 and 15, and the density of water 1.0225. so the total of this is 4,981.5, and this 47.5 is the TPC. So we have to divide this, so we have 104.43, so this is in centimeter, so we had to divide it into 100 to get this into a meter, so we have 1.04 meter. So in change of trim, so trimming moment divide the MTC1 cm, and to find that trimming moment we had to multiply the weight and distance from the ship to LCF to hold one, from ship LCF to hold one. So this is the weight or the displacement, and the distance from ship LCF to hold one, so this is the LCG and the LCF, and not LCG. This is the LCG of the hold number 1. So this one LCG negative. So and this is the LCF of the cargo hold. So why we didn't get the negative sign? Because if negative sign of the LCF and positive sign of LCF, we don't need to subtract it, we need to add. So we're going to add these two. So 63.67, so multiply to displacement or the weight, so we had 317,172.105, and divide to the TPC, not TPC, the MTC1 cm, and this will regard to the from the given below of the hydrostatic table of Virgin Marana, and we have the total of 572.30. So in centimeter, so in getting this into meter, so we had to divide into 100, so we had 5.72 meters. So change of draft. So in change of draft, distance from EPP or AFP perpendicular to LCF to length length, breadth, perpendicular, breadth, length, breadth. So times change of trim. So distance from EPP to LCF is, we need to find the EPP. So LPP is the half of LBP. So our LBP is 174. So we have to divide this into 2, and LCF is 0.28. So we need to minus it. Yung minus natin kasi nasa positive ang LCF. So if positive siya, nasa unahan. So dapat i-minus. Minus natin dito. So minus times the change of trim. So we had 0.49 times the change of trim, 5.72. So we had 2.80 meter. So change of forward draft, we're getting the change of forward, we had to change of trim minus change of aft draft. So our change of trim is 5.72 minus 2.80. So we had 2.92 meters. So to find the new draft, our department draft is forward mean of is 10 meter. And our departure weight, our this one, body listen cage, or the weight, our body listen cage. So we're going to add this. So 11.04 or 0.04, 11.04. So apparent draft. So in change of draft, this we're going to put it in the draft, aft and forward. So in getting the new draft, so we have to add this and subtract this. So 11.04 plus 2.92 meter is, we had to 13.96, and 11.04 minus 2.80 is equals to 8.24 meter. So in getting the mean is, we had to add this 2 and divide into 2. So we had 11.1. So our trim is 5.72. So solve for new kg. So total vertical moment to divide total weight. So the total, this is the total of vertical moment, thus plus our weight here before it was going to body listen cage. So this is our weight, departure weight, and 8.0 is our given, and the total weight is, in going to total weight is, we had to the displacement plus the body listen cage weight, displacement and dead weight, not dead weight, body listen cage. So divide, we had new kg of 8.68. So the new GM, in getting the new GM is km on departure from the hydro table minus the new kg. So we had 12.66 minus 8.68 is, we had the new GM of 3.98. So in getting the free surface correction, GGO, so length times breadth cube times density, divide the 12 given, and the weight of weight or the displacement, and the weight of the body listen cage in departure. So 18 and times the 27 the b cube of breadth cube and the density, divide the 12 times the total of displacement. So we had to, this is the total and we had to divide it, so divide it, so we have a GGO, new GGO, or the new GGO 0.85. So in getting the new GOM, so new GM minus the GGO, so 3.98 minus 0.85 is equals to new GOM 3.13. So for now, I'm going to, so that was our task 1. So in the task 2, so start the other circulating system and isolate the leaking pipe or the collar and other etc. And close the inlet and outlet values of the affected system to stop the leak. And the last is, when a loss of hull integrity is known or suspected, personnel should not be sent onto decks that are being regularly submerged or deeply awash. So that's all my answer, sir. So I don't have answer of the task 3. So sorry, sir. Thank you.